Actual chip formations and classifications, or you can say actual chip forms and classifications. Desired and not desired. First we see the desired, C-type and E-type broken chips, medium helical broken chips, short helical broken chips, and last one is long helical broken chips. This four types chip is desired section. Next section is not desired. There are two types. First one is long helical unbroken chips, and next one is long and snarled unbroken chips. So these all are the actual chip forms and classifications of chip. Chip formation in metal machining. Since the practical machining is complex, we use orthogonal cutting model to explain the mechanics. In this model, we used wedge-shaped tool. As the tool forced into the material, the chip is formed by shear deformation. There is three pictures. See the first picture. There is a workpiece and a tool. And with the help of a chip that has a rough surface, chip thickness, shiny surface, and rake angle. And the tool has rake surface, flank surface. And see the workpiece, there is uncut chip thickness, shear plane, shear angle, and clearance angle. Next picture is a positive rake, and last one is negative rake. Chip reduction coefficient. Chip reduction coefficient is defined as the ratio of chip thickness to the uncut chip thickness. This factor is an index of the degree of deformation involved in chip formation process, during which the thickness of layer increases and the length shrinks. In the USA, the inverse of chip reduction coefficient is denoted by RC and is known as cutting ratio. The following figure shows the formation of flat chips under orthogonal cutting conditions. From the geometry of the following, we can write chip reduction coefficient is equal to A2 divided by A1, and from the picture we can write AC by AB, and AC is OA cos beta minus gamma naught, and AB is equal to OA sin beta. We can write cos beta cos gamma naught plus sin beta sin gamma naught divided by sin beta. After calculation, we find cos gamma naught divided by 10 beta plus sin gamma naught. Therefore, 10 beta is equal to cos gamma naught divided by chip reduction coefficient minus sin gamma naught, and beta is equal to 10 inverse cos gamma naught divided by chip reduction coefficient minus sin gamma naught, which is a shear angle. Velocity relationships. There are two pictures. The following figure shows the velocity relation in metal cutting. As the tool advances, the metal gets cut and chip is formed. The chip glides over the rake surfaces of the tool. With the advancement of the tool, the shear plane also moves. There are three velocities of interest in the cutting process, which include VC, which means cutting velocity, VF, which means velocity of the chip relative to the tool. It is called chip flow velocity, and Vs is the velocity of displacement of formation of chip relative to the workpiece along the shear plane. It is called velocity of shear. Velocity relationships. According to principles of kinematics, these three velocities, their vectors must form a closed velocity diagram. There is a velocity diagram. The vector sum of the cutting velocity Vc and the shear velocity Vs is equal to chip velocity Vf. Therefore, we can write Vf is equal to Vc plus Vs. Then we can write Vf divided by sine beta is equal to Vc divided by sine 90 degree minus beta minus gamma naught plus Vs divided by sine 90 degree minus gamma naught. After calculation, we find Vc divided by Vf is equal to velocity strain factor. Velocity relationships. Cronenberg derived an interesting relation for chip reduction coefficient which is of considerable physical significance. Considering the motion of any chip particle as shown in the following figure, to which principles of momentum change are applied. This equation demonstrates that the chip reduction coefficient and chip flow velocity is dependent on the frictional aspects at the interface as well as the orthogonal rake angle, which means gamma naught. If gamma naught is increased, chip reduction coefficient decreases because our equation is chip reduction coefficient is equal to e power viscosity multiply pi by 2 minus gamma naught.